Hey everyone, Chang here and welcome to my channel. For this video, I wanted to serve as a sort of introduction to proof. Now, every time we hear proof, that is one of the scariest things in math, even scarier than all those hard computations and what to do, and it is proof. The idea of proof, when we first learn, is sort of one-sided. You start from the beginning and then you end with the result that you want. And after you get that result, you need to know every single step. So your mind's eye have to already visualize and know each and every one of the steps that I need to take to demonstrate the result. But that's not the case. And as I learned more and more proof, and it was a struggle, right? I hated proofs. I realized there's a bunch of different ways, but the key is to know this. There's no one set way to prove something, right? The idea of proof is you have a start, you have an end result, and whatever way, shape, or form, you're trying to use a logical reasoning, a logical way to follow from what my basic assumptions are, what am I given to, in the end, I can say with basically a good certainty that that's the end result. That's all it is. And therefore, there's a lot of different ways to go about proving things. I'm not going to go over to a lot of proof because I'm going to try to make videos on specific proof techniques. But I want to start off with this one. This is a very common proof and a very common result. The idea of square root 2 is not a rational number. Let's just make sure it's obvious, not rational number, right? Here's the thing. This has an interesting history, and you guys can look up the history about the whole denial of the Pythagorean theorem, because if you put 1 on both sides, you know, the A and B, the C is going to be the square root 2, and then the whole nonsense. And the other one is just the idea that, oh man, it has to be a rational number. This is also known as the whole reason irrational number exists, right? Because it ends up being proven that this can't be a rational number. So today what I'm going to use is basically called the proof by contradiction. And I'm going to go into extensive detail in the future of this particular proof concept because I love it, right? Proof by contradiction. Now, what it does is, the key is you assume the opposite. You assume truth. Okay? And then afterwards, after you assume that whatever statement, the opposite, is true, right? You come into a contradiction as you work through the problem. And therefore, the only way that contradiction can be resolved, or why it happens in the first place, is because your original assumption is false. And that's the proof. So, if we're looking at this, the end result is that the square root of 2 is not a rational number. So, we're going to assume truth, basically the opposite, right? We're going to assume truth, basically square root 2 is a rational number. That's our assumption. Okay, now, what does that mean? Well, that means that we can write some number m over n, right? Right here is the most simplified form. Simplified form. Okay, we're saying basically square root 2 is equal to m over n, where m over n is its most simplified form. Remember, in fractions you can always have a bunch of different variations of basically the same number. You know, 1/2, 2 over 4, you know, 3 over 6, so on and so forth. But we're saying it's simplified to the minimum. Okay, so m and n is the most simplified form of the fraction, and that equals square root 2. So what that means is that, well, let's just rewrite it right here. Square root 2 equals m over n. And we don't like the square root 2, so what we're going to do is we're going to just square both sides. Okay, so that means 2 equals m squared over n squared. Now, if we multiply n squared on both sides, right, we basically get 2n squared equals m squared because the n squared cancels out. Alright, so here's the key. 2n squared equals m squared means, because it is multiplying by 2, this right here is an even number. So, since 2n squared is an even number, and m squared means that it's m times itself, the only way that m squared can be an even number is if m is an even number. So therefore, right, the result or the consequence is that m is even. Even. Okay, cool. Not too bad. Can't really see how it helps though. But if we look at it differently, well, since m squared is an even number, right? That means m is an even number, and since m is an even number, we can actually rewrite it, right? We have 2n squared equals m squared, but we're gonna say m equals, I don't want to say O because O looks like a 0, P. All right, let's just say 2P. Okay, because m is an even number, you can write it as it's 2 times some smaller number. Well, in that case, it's going to be 2P. So if we rewrite this, it's going to be 2n squared equals, right, 2P squared in place of m right here. Okay, well, in that case, we have 2n squared equals 4p squared. Okay, divide by 2 on both sides, and then you have, let's go down here, n squared equals 2p squared. So notice this. This reasoning is going to be the same as this. Because n squared equals 2p squared, that means n squared, right, is equal to 2p squared right here. That means n squared is even, and that means the result is that n is even as well. Okay, so let's walk through this again. Assume that square root 2 is a rational number. We want it to be its most simplified form of a fraction, because that's what rational number is fractions, right? M over n. And then we square both sides, and we did all this, right? You know, multiply n squared on both sides, and all of a sudden we figure out that m is even. Okay, cool. But then if m is even, that means we can rewrite m into be another form, right? 2 times some other number. So if we replace it, all of a sudden we come up with the result that n is even. But if m is even and n is even, that means m could be written as a number multiplied by 2, n can be written as a number multiplied by 2. That means the top and bottom is going to have 2 times some number, and that's going to contradict our assumption. Because guess what? We said that m and n is its most simplified form. That means there should not be any number you can cancel out. That is it. But after reasoning through it, all of a sudden it says that m and n is not. Well, then the only problem is, I mean, we can always say m and n is any number that's most simplified. So everything here is true. Here is just basically our reasoning. So the only thing that could potentially have caused this hiccup is our initial assumption. Square root 2 is a rational number. But since that's the only thing that's going to cause this hiccup, we can now state definitively that this is not true. Therefore, the opposite must be true, that square root of 2 is not a rational number. Alright, so hopefully this made it a little more clear. The goal of this is, I mean, I think everyone should see this proof one time or another in their math study. The understanding of square root 2 is not a rational number is pinnacle, because that's usually the prime example of demonstrating why rational number exists and irrational number exists. Because up until that point, it was always assumed that any number can be written as a rational number. Square root 2 is the prime example of the existence of irrational number, and we go on from there. So this one is a little messy, right? And I also wanted to show you guys this. Yes, I reasoned it out. I've learned it before, so it flowed a little better. But notice that I am jumping all over the place, and that's how proof is normally done, right? There is very rarely, I'm not going to say never, but very rarely a person who could just jump from point A to point B without going through what we call scratch work, right? Just trying to reason things out. And guess what? This happened to work because I've learned it before. I could use other proof, and sometimes different approaches might not work as efficiently, right? And you might run into hiccups, you might get stuck, and that's normal. So proof is scary, but there's a lot of different techniques, but that's all it is. Your end goal is to show that a specific result is either true or false. and then just explain it in whatever way possible. I wrote some. It's not completely mathematical. Notice that I'm using words written down, right? There's no concrete way to prove things. Of course, there's gonna be different notations, and then you'll see crazy stuff like this one right here, which is common in a lot of proof books. And it looks like a brainiac symbol right here, and that means therefore. Or you'll see stuff like this as ST as such that, and so on and so forth. And yes, eventually I'm gonna go into more details about the different notation, but the idea is that you're talking, you're reasoning, you're using logical deduction, you're explaining your train of thought, and that's all proof is, right? It might not be elegant, you might not write in the most simplistic mathematical terminology, but as long as you can show how I got from A to B with all your scratch work and then reorganize it, of course, so that's easier to follow, then you're good to go. So, very long-winded way of introducing proof, but I'm hoping that this will get you a little more comfortable, and I will definitely be presenting different proof techniques in future video. Thank you for watching. See you in the next one.